So we have learned about how we can find a BFS to a balanced transportation problem. Now let's look at another important component in the simplex algorithm, which is called the pivot. If you recall the simplex algorithm that we use to solve the linear programming problem, whenever we have a BFS, we will determine the entering variable, and then we will perform ratio tests to know which variable must be the leaving variable. And then at this position, it is called the pivot. We perform elementary row operations such that we will get a new BFS, and then the variable is different. What we would like to become the entering variable enters the basis, and then the leaving variable leaves the basis. However, the new solution is still a BFS. So the simplex algorithm needs to keep the BFS still become a BFS, but hopefully with a better or at least the same objective function value. So that's the role of pivoting. Okay, so we keep the BFS still as a BFS, but hopefully with a better or at least the same objective function value. Now we're going to see how this may happen for a transportation problem. So these are the 4 steps in the pivoting procedure for transportation simplex. It's actually similar to what I just said in the previous slide. The key in pivoting is first we need to know who should enter the basis. In other words, which one is the entering variable. And at the end, we need to say who should leave the basis. And then in between here, what we need to do is that we need to make sure that whatever procedure that we use such that somebody can enter the basis and somebody else leaves the basis, we need to make sure that the BFS is still a BFS. In the case of transportation problem, remember that the BFS must have m plus n minus 1 basic variables and they must not form a loop. So that's the keys for the pivoting in transportation simplex. So let's go through the pivoting procedure in transportation simplex step by step using an example. Okay, so in step 1, at this point we just suppose that we know that x14 should enter the basis. We have not talked about how we know about this, but at this point, let's just assume that we know x14 should enter the basis. In the form of the table, x14 is the cell 1, 4, first row, fourth column. Okay, so this is the cell. And then in step 2, it says that find a loop that involves the entering variable x14 and some basic variables. So we need to find a loop involves the entering variable and all the variables as long as they are basic variables. Okay, so let's try to create a loop. From here, because loop says you must go, any 2 consecutive cells must have either the same row or same column. So let me see if I go there. It's the same row, so it's okay. And then let's say I go down there. Again, it's the same column, so it's okay. And then I go there, skipping 1 cell in between them. Because if I include this cell, then it will not become a loop because we will have 3 consecutive cells and it is not allowed in the loop. From there, I go down again, so it's the same column, the same row, and finally where I start and where I finish, they are in the same column, so this is a loop. Now in step 3, we are going to use the loop that we've got before and then labels the cells, either they are even cell or odd cells. So even is like starting from the entering variable, it's 0, and you can think of this as 1, 2, 3, 4, 5. So in other words, this will be even because it's 0. This will be odd because 1. Then even again, odd, even, and odd. So that's for step 3. In step 4, find the smallest value among all odd cells. So you only look at the cells that you labeled as odd. This, and this. And then take the minimum of the values that are inside those cells. So we take the minimum between 35, 20, and 30. So the minimum is 20. Once we have got the minimum value, which is 20, we call it theta, and then we are going to decrease each odd cell by theta and increase each even cell by theta. So for all the odd cells, we're going to put minus 20 because it will decrease them by theta, which is equal 20. And then for each even cell, we will do plus 20. Okay, so for odd cells, it is minus 20, minus 20, minus 20. For even cells, it is plus 20, plus 20, and plus 20. In other words, we are going to make x14 enters the basis, and then x23 leaves the basis. So in this case, when you see 20 minus 20, you don't write 0 there, but you just leave it as a blank cell, because we are going to say that x23 is leaving the basis and becomes a non-basic variable. So this is the result. You can see, as I've said before, now the cell 2, 3 becomes an empty cell because it leaves the basis and now it becomes a non-basic variable. On the other hand, x14 or the cell 1, 4 now becomes a basic variable. Previously it is an empty cell. Now it becomes a cell with the value 20 inside the cell. So now you can see we have a new BFS, and it's still a BFS because the number of basic variables is still m plus n minus 1, and then those basic variables, they do not form a loop. So that's how we perform the pivoting for transportation simplex. So here's one quiz question to check your understanding. In the new BFS, which is this bottom table here, can we write 0 in x23? So in this cell 2, 3, row 2, column 3, can we write 0 there? Out of these 3 statements, pick one that is true. There will be a pause on the video to give you the time to think about the answer. The answer is no, because x23, or this row 2 column 3, is now a non-basic variable in this BFS. So you must not write anything in that cell. Just leave that cell blank. If you write anything inside the cell, it means that we will have 1, 2, 3, 4, 5, 6, 7 basic variables, and it is not allowed. We must only have 6 basic variables because in this case there are 3 suppliers and 4 demand points, so we can only have m plus n minus 1, which is 6 basic variables. That's why you must not write anything in this cell. Okay, so we have talked about how we may find the BFS, how we may perform the pivot. So now I guess we're ready in the next video to talk about the whole transportation simplex procedure.